Yeah, and you have Desmos to guide you now and do these things. So it's much simpler than it used to be. All right, to solve an optimization problem, determine which combination of values of two variables results in a maximum or minimum value of a related quantity. So basically what we're going to be doing is you're going to be drawing out shaded regions of 3 or 4 lines, and then you're going to use their boundary points to substitute into an equation at the end to give a maximum or minimum problem. Yes, sir.
Congratulations first.
Appreciate it. Thank you.
Second. You'll have to ask about 5 and question at the end of class.
Yep. 1 here, 2, 3, 4. I got enough. I can move this over and go at
Just
the
near
end.
the end.
Yeah.
You'll be quiet in here then?
Oh, yeah. Yeah. Okay. So here's the first thing. So I need you to write this down because each of these you're going to have to do on every single question. Okay. So the first thing that you're going to do is you have a defining statement. What the defining statement is it's you telling me what does X and Y represent. That's what that defining statement is. So what do X and Y represent in the question? The second part that you have to do is restrictions. Now the restrictions are the restrictions that are added to the graph. They will always look like X is an element of, Y is an element of. Those are your restrictions. Now, when you're doing an actual word problem, the restrictions are the majority of the time going to be whole numbers. All right? Because we're going to be looking at how many hamburgers and hot dogs can I sell? Well, you can't sell parts of a hamburger or a hot dog. You have to sell wholes. So you want to make sure that we know what they are. It could be integers, could be real numbers as well. But for the most part, that's it. Constraints is the next part. And this is the part that's the complicated part. Okay? So the constraints part of this is the inequalities. So the equations of the inequalities. So those go on it. So those will be the lines that you're going to graph. So they'll have greater than or less than values to them. And then the fourth part of this is your objective. And the objective is going to be an equation as well. And it's going to be, are you finding the maximum or minimum of your set values? Okay, so when creating a model or first represent the situation algebraically, include a defining statement of the variables in your model. So that's what do X and Y represent. A statement describing the restrictions on the variables. A system of inequalities that describes the constraints. An objective function that expresses the quantity to be maximized or minimized in terms of the variables. Then you create a graphical model by representing the system of inequalities graphically. This helps identify the feasible region for the solution. The feasible region, so what you were doing the other day is you were graphing two sets of inequalities. The feasible region is the region that gets shaded by both. That's what the feasible region is. All right? Okay, so let's look at a couple examples, and we're going to follow them through. You'll need Desmos, so take out your phones right now. Just set it to the side. So the first thing that we're going to do, I want you to set up this, and we're going to add to it using the information that's provided to us. 4 teams are traveling to a baseball tournament in cars and minivans. All right, so the first thing that I'm going to do, very first thing, I'm going to read the whole question once. And then I'm going to go back and I'm going to extrapolate the information from it and add it to the board. Okay? 4 teams traveling to a baseball tournament in cars and minivans. Each team has no more than 3 coaches and 10 athletes. Each car can take 5 team members, and each minivan can take 8 team members. No more than 5 minivans and 11 cars are available. The school wants to know what combination of cars and minivans will require the maximum or minimum number of vehicles, create and verify a model to represent this situation. Okay, so we have 4 teams, a maximum of 13 players or 13 people per team. Okay, taking cars and minivans. And we want to find out what the maximum number of cars or the minimum number of cars and minivans we got to take. So the first thing I do is work on that first line. What is in that first line that I could add to this board?
4.
No, not yet. Read that first line again.
Here, 5 and 11.
First line. 4 teams are traveling to a baseball tournament in cars and minivans. What part of that should go up here?
Cars and minivans.
Cars and minivans. Cars. I'm going to change the color so we know it's pertaining to this question. Cars. Minivans. Okay, simple enough. Can I have a part of a car or a part of a minivan? No. So what are my restrictions then? Whole numbers. Now, in theory, could this be natural numbers?
What's that?
Good question. What's a natural number? What's the difference between a whole number and a natural number? Go ahead.
I think natural numbers start with 0 and whole numbers start with natural start with 1
Yeah,
and
there you go.
whole numbers start with 0.
Yeah. Only difference between natural and whole numbers is in whole numbers you can have 0. In natural numbers you start with 1. So theoretically it could be, but is it possible to get all of the team in just cars or minivans and not have the other? Yes. So that's why we went with whole numbers. We could have 0 cars or 0 minivans. That is a possibility. All right. Because it's whole numbers, the reason that we call it a restriction is because now it restricts what your graph is going to look like. Where is your graph going to be located in this particular question? Top right. It is going to be in the first quadrant only, this graph. All right? So all of that, we just did this first 2 parts in the very first line. Now let's start reading and taking some more out of it. Each team has no more than 3 coaches and 10 athletes. Each car can take 5 team members, and each minivan can take 8 team members. No more than 5 minivans and 11 cars are available. The school wants to know what combination of cars and minivans will require the maximum and minimum number of vehicles. Create and verify a model to represent this situation. All right. So, constraints. No more than 5 minivans. So, Y has to be less than or equal to 5. Let's see. No more than 11 cars. X less than or equal to 11. Okay, we have, yes, go ahead. Okay, I'll look at that. Okay. Actually, what you want to do while you're sitting there, you can delete the app and then look at it. Okay. All right. Now, here's the one that we have to read into it. How many people can fit in a car?
8 or 5.
5, and how many in a minivan?
8.
8. All right. How many players would be the maximum, or how many people is the maximum number for this question? 13 times 4. There's 4 teams. 42. Yeah. Okay. You want to reboot your phone then? Let's try that. Okay. So here's what I need to do next then. How many cars? How many people in the car?
13.
No, in a car.
Oh, 5.
5x plus 8y gives us the total number of people, and the maximum number of people is 42. This is the guy that you are going to struggle with to make.
Is it 52?
Yeah.
52? Monday math, not mathing. Yeah, seems a deck of cards. Perfect. Okay. So 5x plus 8y is less than or equal to 52. That's the part that deals with the people. Now, we go all the way to right here now, the objective function. We want to find out what is the minimum combination of cars and minivans that we can use for this particular question. So I show that like this. M equals. And all the M stands for is minimum or maximum. You can put whatever you want. You can put A for amount. Doesn't matter. X plus Y. So cars and minivans. We want the minimum or the maximum amount. Cars and minivans for this question. So we haven't done the whole pile yet, but there's quite a bit of information on that board. All right. So now what we do is we graph the next step of this. Okay. So I'm going to graph these here, and then I'm going to go back and I'm going to talk about what's happening. All right. So Desmos. First equation was what? Y was less than or equal to 5, yeah?
Yeah.
Okay, so there's the start of it. And again, I'm only in the first quadrant. All right? Second one, x was less than or equal to 11.
All right, just put 1.
I'll come back to that in a second. Okay, now, I just want to look at this for 1 second, okay? Once you've got this down, I want you to set your phone down so I can tell that you're looking at the board. All right. Now, the next thing that we have to do is we need to identify critical points. The critical points identify the boundary of the feasible region. A lot of words there. So the boundary of the feasible region in this particular case is this right here. There's the feasible region in that area, because that is the area that satisfies both those equations. I shaded below and I shaded to the left. Well, where is that? That's in this region right here. That region is the only region that covers both. I don't worry about this part of it, okay? Because that part of the graph right there doesn't matter, because we were talking about whole numbers only. So theoretically, I shouldn't have shading here. I should have dots on all of the intersection lines, okay? But we'll worry about that in a second. Now, the critical points of this graph are right there. That one, that one, that one, and that won't give me 0 and 0, but 0 and 0 is a critical point. Okay. So far, if I was just doing 2 graphs right now, the critical points are the outlining points of the region that is shaded by both. Those are called critical points. So what I want you to do is I want you to write that down here. Actually, sorry. Just wait. I'm gonna do that different. I'm gonna go X, Y. This is what I want you to write right now for this. Okay? And what goes in there, I'm just gonna write this here so you know the word. Those are called critical points. Okay? Now I have to put the third graph on there before I actually do all of the critical points. But that's what this is. So I take the critical points and I put them on this graph here. And as they're on that graph, or sorry, that chart, table of values. It's not a graph, it's a table of values. On that table of values, I actually mathematically solve it to find out which one is the maximum and minimum of the critical points. But I have to now graph this. So let's go back to here. I have 5x plus 8y is less than or equal to 52. All right. So now I have to look at this and I have to figure out where are my critical points. So the feasible region. All right. Okay. Put that line on there, shade that region, and then I want you to put your phone down again so you can watch and see what's happening here.
Are those? Those they are. Oh, they just showed up as like highlighted dots.
Yeah, possibly. Okay. Okay, everybody's phone is down. All right, now watch what happens here. Okay, first things first. The shaded area has to be a part of the entire graph here, right? I need to do this. That's 11, that's 8. I want to expand this, so I need to go here, here, minus 2, 11, minus 2, 8. Okay. Where does the feasible region occur here? Where does it satisfy absolutely all three of the shaded areas? That's the part that we need to find. Okay. So if I do this,
That's supposed to be 11.
what's that? Oh, this should be 11 here. Thanks, Ryder. There, that changes things. Okay. So now, this slide this a bit this way. There we go. Okay. So critical points for this graph then. 1, there, 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 and 0 and 0 I have to include. I don't want to tap on it because it won't give it to me. All right, what do you notice about 2 of those critical points? The decimals. So I can't use decimals in this question, can I? All right, so we are going to still add those in, but then we have to look at, okay, whereabouts are the feasible regions here, or the feasible areas? All right, so now I'm just going to follow back into the book here. So I have 5C, 8M, less than or equal to 52. I graph the inequalities on my calculator. For the inequalities for C, I use the window function to set a range from x equals 0 to 11. Then I determine the intersection points of the boundary lines for the feasible region. The intersection points are 0, 0, 0, 11, 1, 11, 5, 3, and 5, 0. All right, so those are some of the boundaries. I gotta make sure I got this right because this does not match with what they're doing. So what I would do next, and it can't work for this question the way it's written because I have a decimal here and a decimal here. What I do is I take those values now and I put them in right here. So what I want you to do is I want you to add those values onto here for right now. Include the decimals. Include the decimals for right now. So 0, 0, and 0, right? 0, 5, 1. Eight.
Fires are zeros, right?
Oh, I got that wrong. Well, let's do this one. This is 10.4. All right. Now, obviously an issue with this question because I have decimals as part of my answer. So it does not work ideal. Okay, so what is the maximum amount of vehicles that would take in order to get these 4 teams to a tournament? The maximum number is? It's the largest M value, 10.4. And what's the least amount of vehicles I would have to take?
Zero.
No. Well, yeah. But I wouldn't get anybody to the tournament though. Okay, this is a part of it, but this is your correct answer for minimum. 5. Now think about this for a second. If I take 5 minivans to the tournament, how many people total can I take?
Maybe 32.
45.
Or 8 times
40.
5.
8 times 5, which is
40.
40. So if I were only to take 40 coaches and athletes, I could use 5 vehicles to do that. Any more and I couldn't take the 5 vehicles. The maximum number of vehicles I need would be 10.4. That's cars. That's cars, right? So how many people can I put in a car? 5. What's 5 times 10.4?
54.
Close. 52. So if I had to take the maximum number of players, and I would need to take 10.4 cars. But I can't take 10.4, so how many cars would I have to take? 11. I would need at least 11 cars to make this happen, which is, checks that off there. If I took 5 minivans, the most people I could take is 40. If I took 11 cars, I could take all 52. All right, I would take 5 and 10 of the vehicles and 2 extra in the last vehicle.
How do you know like where like the critical points go on that thing?
I do it by XY. So I've defined it up here as X being cars and Y being minivans, right?
Yeah.
Okay. So I make a table of values of X and Y. And then whatever this objective function is, I do that to X and Y. In this case, it was add.
Okay.
Okay. So I'll do another question very similar to this. Okay. I'm going to show you one more question. And again, one of the things that you're going to have to do is write out the equations, and that's going to be the difficult part, is actually writing out your own inequalities. All right, so I'm going to pick a question in which we got to write out our own inequalities. Go to page 169, please. Actually, I'm going to pick a better question than that. I'm going to do a similar question. My bad. 171. Okay. So I go back to this again. So the first thing I want you to do is write this out. So put this down.
Which question?
Okay. We're looking at question 6 on that page. Actually, we'll do 5. I think that's a better one. We'll do 5 on that page. Okay? All right. Yamni collects stamps and baseball cards. What's the first thing that I need to do there?
Stamps and cards.
Stamps and cards. So let's write that out. X, stamps. Y is cards. Next step, go over here. Whole and whole. Okay? Again, you can't buy a part of a stamp. You can't buy a part of a baseball card. So now we got to look at the restraints. That's the next part, constraints, sorry. He has at most 100 stamps and at most 75 cards. So how do I show at most? Okay, but what is it exactly? How would I write out that statement?
Y equals greater than equal to.
Maybe less than equal to,
How come, Tosh?
because it's like all the numbers that are less than, what is it, 100? And 100.
Okay, so how do I write that out? The word at most means then that it has to be less than that amount. So how would you write that out?
X is less than or equal to 100.
X is less than or equal to 100. All right, on your piece of
Excuse me,
paper.
interruption, Colton Albert Geeson and Corey Corns return to room 23.
Wherever you're at right now, I want you to write the next line out for the amount of baseball cards. It gives you something specific. I want you to write it out. Write out the baseball cards. What is the baseball card inequality?
What's that mean? Or just like what it is?
Yeah.
Y equals less than equal to 75.
Y is less than or equal to 75. Do we agree with Zach?
Yep.
Yeah. So far, so good? Okay. Then there's a little piece at the end of that statement. What does it say?
It costs them.
Nope.
There are more than 150 items.
Nope. You guys went too far.
But at least one of each.
But at least one of each. How do I show at least one of each?
You like greater than 0.
Greater than 0? We agree? Okay.
Like X, what's it, E thing again?
No, not yet. Oh, I know. Yeah, that's a good point. I like what Blake is saying here. We could change this to natural numbers. You could, but we're not going to. Don't do that. Kane, you had your hand up.
I was gonna say the same thing.
Oh, you're ready? Okay. I want to write down, rather than greater than 0, I'm going to write down greater than or equal to 1. Okay? Greater than 0 is not incorrect because we've established that it's whole numbers. So that can work. But I know what the answer to this question looks like, and then they want greater than or equal to 1. And the reason for that is the boundary lines matter. Okay? So that's the next two that I want you to write up. X is greater than or equal to 1. Y is greater than or equal to 1. That's all of that. All 4 of those are in the first statement, the first line. Okay, what does the second line say? There were no more than 150 items in total. How do I show no more than 150 items in total?
Less than or equal to.
Okay, but be specific to the question. How do I write it?
X plus Y is less than or equal to 1.
X plus Y is less than or equal to 150. So far, so good? All right, now, the objective part of this is the next line. What does the next line say?
The cost.
The cost. Each stamp cost him 10 cents and each card cost him 50 cents. So I'm going to put my amount equals 0.1x plus 0.5y. Okay? All right, I want you to put that on Desmos and see if you can identify the critical points yourself. So put this on Desmos. I'm going to write this out here, my table of values.
Wait, what do we put? We're putting 0.1x.
No, your constraints. You graph your constraints. And then you have to get your critical points after that.
Yeah, but every single one.
Yes. Okay. All right. Critical points now. Kind of jam them in here for you. I want that one.
How do you know which ones are critical points?
Because your shaded region for all 3 have to be in that area. Okay, so that's a great question. Blake just asked, how do I know which ones are the critical points? Well, when you look at the shaded region, it has to be a part of all of those. So the reason, again, that I did x equals greater than or equal to 1 is for those critical points. 1 in 149, 1 in 75, and then out here is 75 and 75. Those are the only 3 points that satisfy where all of the shades happen. All right. Anybody have an issue finding those critical points? Yes, sir.
I just don't know where to find them.
Okay. So you're looking at this graph the way it is right here. All right. The area in which that all of this is just shaded, like it's got to be less than this. There. That's there. Okay, now I'm going to check this and see. Is that,
That doesn't seem right.
what's that?
Because shouldn't
Should
like that 1 and 149, shouldn't y be less than 275?
Why? Yeah. So it should be down here somewhere, right here. That should be it there. No? Oh no, 75. Oh, 1 and 75 is here. Okay, I'm gonna try this manually now and see if I can get this to work. Okay. All right, I'm gonna place these in. All right, so the first one I'm gonna do is, okay, so there's, and it's shaded this way. The second one I'm gonna do, shaded up this way. So this one is y is greater than or equal to 1. This one is x is greater than or equal to 1. All right, and then I have this will be y is less than what? Y is less than 75. So I'll put that here. So that's got to be below that. And then x has to be less than 100, right? Yeah, x has to be less than 100. So right now I have that. Okay. So now, the shaded area is this square right now. Okay. Now, the last line I got to put in is that 150 line. Now, where does it cut across? So up here, this is 75 here, right? So there is 150 up there. And out here is 150. So that graph should look something like that. So your critical points then would have to be here, 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 and here. I believe those are your 5 critical points. So if y is equal to 75, so this point right here should be 75 and 75, right? This yellow line represents, what is that? X is less than 100. So then this coordinate here would be 150. This one right here is 1 and 100. No, 1 and 50. No, that's not right. It's 50 and 1. I'll explain myself in 1 second here.
On decimals, it says 100.
Yeah, it like highlights the points.
50 and 1. It says 101.
Yeah, and then one
Well,
instead
that
of
makes sense, though.
150, it's down low and
It's
it's
only
mostly
putting x as the point above it.
Oh yeah. Okay. Right. I was thinking what that was. Yeah, my bad. So this would be 101. Okay. Down here is 1 and 1. That's a critical point. And then the other critical point will be right here, which would be 1 and 75. Yeah, thanks. Okay, so those are your 5 critical points because the only area that is shaded that satisfies, and actually I shouldn't even do that. My bad. I want to get you used to doing this. What should I do there instead of shading? Dotted. So those would be dots in there, not lines or anything like that. Okay, so your critical points. Now, I did not get those critical points on here, so let's find them. Mine's hard to see. That's the part of the problem. What's that?
Hey, it's zoom out.
I can't hear you.
Zoom out.
Zoom out if you can.
I'll zoom out.
It's,
The grade on.
it's,
So here, here. Should be one right there. Yeah,
Yeah, they show up. Pretty.
this one right here. There we go. I'm missing one, am I not?
There's one
Yeah.
above 101. So one.
One above this?
Yeah.
Like it's
Up.
100.
Where the two lines meet underneath the 7.
yeah.
Right here? Oh, yeah. Yeah, perfect. Okay, there you go. Okay, so where do I put those now? I gotta put those all on that table of values now. Okay, so let's go back to this. I need you guys to read them to me. So first one is 1 and 1, right?
Yeah.
What's the next one?
175.
1 and 75,
75 and 75.
75 and 75,
150.
150,
101.
101. Okay, those are my critical points. So now the question states, what is the minimum solution to this system and what does it mean? So now how much money we have to figure out how much money they're going to spend. Yes, sir.
Doesn't it matter like what order you put them in?
It does not. As long as the X and Y's are together.
Yeah.
Okay. So if it purchases 1 stamp and 1 hockey card, how much money?
60 cents.
60 cents. 26. 1 stamp and 75 hockey cards. What do you got?
You said it was 5 times.
75 times 5.
Maybe 0.5. Is it 37?
Okay.
Yeah, 37.6.
37.6.
I said that first.
$37.60. All right. 75 stamps, 75 hockey cards. I think they're hockey cards, but 75 stamps, 75 cards.
Baseball.
Baseball cards. How much?
38.25.
Okay. 150.
$35.
Even.
Maybe. Yeah.
We agree with them? 100 stamps is $10. Right?
And then it's just 50 divided by 2. Because your times went by 0.5.
Okay, so what did you say it was?
35.
Is this 35?
I don't know.
Yeah, it is 35.
Okay. And then the last one is what?
10.
$10.50. Okay.
Wait, I get 38.25 for the 75
Don't worry about it.
I keep getting 45.
Just do your math.
Yes, I'm at 45 too, that's better.
I also get 45.
Like, that you said that. I said, no, I didn't. I didn't even do that one. Just till I done that.
And blame that your wrong answers on me.
Okay, so the question asks, what is the minimum solution to this system? So it says create an algebra. Yannick collects stamps and baseball cards. What is the minimum solution to this system? Well, the minimum solution to this system is 60 cents. And that is him purchasing one card and one stamp. What's the maximum amount of money he would spend if he had all of the criteria? $45. Okay, so the difficult part of this whole thing is figuring that out. Break down each sentence and figuring it out. That is the ultimate length of a question that you're going to get. The question will not be harder or more difficult than what we just did there on the board. That's the longest question you'll see. Okay? All right. You need to go back now to, and that's at 6.5, so we're not even close to there.
6.
And 6.6. You need to finish off to the end of 6.3 if you haven't already done that. That has to get done for tomorrow. So get after it, please, and thank you. Any questions? Piper? Okay, so you're finding out where all the lines intersect, and you're looking at where all the shading occurs for each of them. That's how we have to do it. It'll take time, and if you can't see them, sometimes you can just, all right, so there's one line. It intersects with that line right there. Okay, then I put this line on there. Well, it also intersects down here. So now I have 2 intersection points. So all I'm doing is adding this to this. Oh, there's a 3rd intersection point, Piper. There, and then down there is your other intersection point. So you can actually just take all of these off and go one at a time, and then you'll find out where all your intersection points are. All right? And I did that by clicking on the circle here to get rid of the shade. Okay?
That's,
All right.
that's not right.
You take, yeah.
It's not right.
Well,
That one.
this one is. This one's off, this one is.
And the one at the top.
All right, get going on that 6.3. Hey, boys, you got work.